Assalamualaikum and hi to all. Okay, so we meet again here for our lecture 6. So the topic is about sampling distribution. Okay, so as we have been introduced in the first chapter, the definition of samples and also population. So basically we are focusing on sample only, and we want to know the sampling distribution, because basically in order for us to conduct an analysis, okay, we take a few samples, like say from a big population, we take few sample 1, sample 2, maybe take some up to sample 4. So this is just for example only, maybe you take 4 samples, okay, and all of these have different mean, of course. So how it is distributed, of course, will give some sort of different, even though you take it from the same population. So this is a basic one about sample. So now we want to focus on sampling distribution. How is the sample distributed? Okay. Okay, so basically, like I've mentioned just now, different samples of the same size, same population produce different sample size. So this is the one, okay, the different measures of this particular event, which means that different sample size have, even though same population, will give you different sample mean. So these different measurements, okay, are given by the standard deviation of the mean. So this symbol, still remember, this is standard deviation, okay, standard error, standard deviation of the mean. So you look here, x bar. So the relationship here stated that standard deviation of mean will decrease as your sample size increases, okay. So if you have more sample sizes, okay, let's say you have more samples, okay, so you will lower down your standard deviation or your standard error, okay, how it deviates from the center of or the mean of that sample, means of that population. Okay, so basically the Z value, okay, look at here carefully, Z value for mean sampling distribution. So this is the formula given, okay, for us to find the value of Z for the sampling distribution, okay. Z equals to x bar. What is x bar? Is a sample mean, okay, and you need to have population mean here. So your sample mean minus with your population mean divided by population standard deviation. Okay, so we want to change the value of your x here to a standard value of Z, and then you can refer to the table of Z table, okay, for us to find the value of that probability. Okay, so now, okay, so this one, population standard deviation, is also equals to standard deviation, okay, divided by square root of your sample size here, okay. So if you look here, okay, this is a normal population distribution, okay, and normal sampling distribution has the same mean. So the mean is of course at the center here, okay. So if the population is normally distributed and then the sample distribution is also normally distributed, how you know that it is normally distributed? It is in a bell shape, okay. So the standard deviation, so like I've explained to you in the previous lecture, okay, the standard deviation is getting smaller as your samples are getting, the more samples are getting smaller, the standard deviation. So standard deviation is getting smaller with how? When your n becomes larger. So it will shorten the, here, it will look this one. Okay, if larger, then it become more taller, okay, and also it is getting more closer to your mean, okay. So this is what it means. You can also refer to the slide of 13, okay, sample distribution for the mean if population is not normal. So this one also we can see that larger sample size, okay, and this is smaller sample size. So this is taller and much more closer to your mean. Okay. So the next slide, okay, is explaining how large is large enough. So please do remind that for most distributions, so any other distribution than normal, and when the n is equals to or more than or larger than 30, it will provide you normal distribution of samples, regardless of population distribution form. Okay, but for if it's stated that it is a normal population distribution, okay, so regardless of sample size, let's say it is already stated this is a normal population distribution, okay, and they give you the n equals to 10, but in the question they already mentioned that it is a normal population, so we still use the same formula, okay, even though it is n equals to 10, because this one is applicable to other distributions. Okay, because that's why it says here regardless of population distribution form. So as long as I give you n more than 30, so it will give you a normally distributed population. Okay, so the next one, in the previous lecture I shared with you the positive z value table, right? So we also have sometimes the question also involve negative value of z, so you can refer to this negative z value table. Okay, the same thing also, but it just giving you the reading for negative. And here is the one that we refer previously, so always remember that the value given here is for the value less than. Okay, so now we move into the example one. Okay, a well-trimmed engine can produce a production at an average, so they give you here 25 seconds, so this is your average or your mu for your population, with a standard deviation of 3. So this standard deviation 3, and then how much is the n of your, which is your sample size, 36. The mean of the sample is 26.2 seconds, so it is denoted as x bar because the mean of the sample. So what is the probability that the sample mean is at least equal to or greater than 26.2 seconds? So how do we solve this? Okay, so you can refer to the previous slide for the formula that we are going to use. Okay, so basically, okay, we start off, we already write the all the information that is given in the question, right? Okay, so how we solve this? Z, okay, you are given x value, so now you put the formula here z. So in the previous slide, if you refer back, you are given this formula, x bar minus mu x bar, okay, which is what? This is sample mean minus with your population mean divided by population standard deviation. Okay, and this one is also equals to x bar minus mu, okay, divided by standard deviation over square root of n, and this one equals to, what do we plug in here? 26.2 minus with 25, okay, divided by 3 over 36. Okay, because you are given here your standard deviation of your population, right? So you need to divide by square root of your sample size here. So if you calculate this, can you please try? This is 2.40, so this one you should be getting this. Okay, so now actually your answer is, you can write it as x bar. It need you to find this one, right? 26.2, but you already convert it into z value, which can be written as pz larger than or equals to 2.4. And how do we find it from this table? This is larger than, right? And it's positive value. So we refer to this because positive value. But I've mentioned to you, this table gives you the value of less than. Now you are searching for more than or equals to 2.4 or because you already convert it to Z, right, for you to refer to this table, actually you are looking for Z more than 2.4 here. So now because it gives you less than, so what do we need to do here? Okay, so basically we refer to 2.4, 2.40, so 0.9918. Okay, so basically PZ less than or equals to 2.4 is equals to 0.9918. Okay, so your Z more than 2.4 is actually equals to 1 minus 0.9918, and you should be getting 0.0082, okay, for that question. Okay, so basically you will be writing 1 minus 0.9918 equals to 0.0082 here. Okay. Okay, now we move to the next example. Okay, so assume that the population has mean mu equals to 8 and your standard deviation equals to 3. Assume random sample size with n equals to 36 has been selected. So what is the probability of sampling mean between 7.8 and 8.2? So you have in between value. Okay, so how do we solve this? So they give to you the sampling mean is actually between 7.8 and 8.2. Okay, so basically the same thing. It's just that because you have less than and more than value, so you just plug into the formula, you convert into Z first, which is actually 7.8. okay, minus with 8, right? Okay, divided by 3 over the square root of 36. Okay, and in the middle, okay, you just can write this formula, the same formula that we are using just now, and now we put the right hand side value, which is minus 8. Okay, divided by 3 over square root of 36. So P negative 0.4, this is what you should be getting, less than Z, because you already convert to Z, right? So how do you get 0.3108? Okay, how do we get the value of your probability here? Okay, so now we look at the negative table. So 0.4 of negative, what do we get here? 0.34458. Okay, so we look at the positive now. 0.4 is 0.6554. So 0.6554 minus with your 0.34458. 34458. Okay, so you should be getting 0.3108 here. Okay, okay, sorry, so this is actually 0. Okay, sorry, so this is actually 0.34458. okay, so you should be getting 0.3108 here. Okay, so as you can see here, we don't know, right? This is the population distribution, but you know that the mu is equals to 8, and you are given sampling distribution in between 7.8 and 8.2 for the value of your x. So when you convert into standard normal distribution, why I say this, because you convert from x to z, right? Okay, we standardize, so you get the value. When you standardize, you need to put z. So you see here, this is sampling distribution mu x bar. Okay, so now when you convert into standard normal distribution, okay, your mu here is equals to 0, alright, for z. Okay, and then your lower and upper value, it change accordingly to what you have count here. When you convert it into z value, negative, in between negative 0.4 and positive 0.4. Okay, so this is how it looks like when you convert your x into z. Okay, now we move into slide number 21 on sample distribution for population proportion. Just now is mean. Okay, so used for category variables, okay, such as maybe you have customers which like brand A or B. Okay, so category, have different categories and we have different desired or preference. So we have some different proportion for this event. So suppose you want the percentage of customers who love brand A represented by symbol pi. Okay, with pi is the proportion of items in the population with the characteristic of interest. Okay, so the sample proportion or portion we denote as rho here is the proportion of item in the sample with the desired criteria. So this is the definition of sample distribution for population proportion. Okay, so we use this to calculate the proportion of population. Okay, so the proportion of the sample is known by two possible value, 1 or 0, okay, to present the existence or absence of the desired criteria. So it must be between 0 and 1, your proportion. Okay, so we move into the how we want to measure or calculate this. So pi equals to proportional population having the desired criteria. Okay, the one that you prefer lah, maybe customer prefer brand A, so that is our desired criteria. Okay, so the proportion of the sample gives the pi is, this is rho, right? X, number of items in the sample with the required criteria, okay, divided by sample size, and it need to be between 0 and 1. So P approximates normal distribution when n is big enough. Okay. So Z values for proportion. Just now it is for mean. So you involve the formula with mean, right? X bar and mu. So now it is proportion. So standardize P to Z. Okay, because just now you standardize X to Z. Now you standardize P, which is your proportion to your value Z. Okay, so how we want to convert this? So you use this formula, Z equals to P, which is your proportion minus your pi. Okay, basically the concept is quite similar because just now we use X bar and mu. Now we use your proportion, and also this is the proportion of the desired criteria. Okay, so still same, divided by standard deviation of your proportion. So you can expand it into this calculation, which is P minus pi divided by square root of your pi in bracket 1 minus pi divided by n. Okay, because your standard deviation of your proportion is equals to this formula, and that's why we can expand this formula into this. Okay, so we look at the example of standardized proportion. Okay, so the campaign manager of a political candidate, okay, makes a claim that 55% of the registered voters favor the candidate compared to his opponent. So the desired one is candidate compared to opponent. So assuming this claim is correct, is the probability that a random sample consists of 300 voters, which is your n here, at least 60%. So now 60%, right? So we write it as in decimal value 0.6. Would choose the candidate against his opponent. So this one is the claim that it prefer candidate compared to opponent. So it is your pi here. Now P is for your proportion. Okay, so proportion at least 60%. So 0.60 here. Okay, so how we calculate for this? Okay, so your P, your probability, so you are given your P here is more than, right? Because we choose the candidate, the probability of samples, random sample consists of 300 voters at least here. So at least mean more than 0.60 here. Okay, so you need to convert to Z value first. So Z equals to what? 0.6 minus 0.55 divided by, okay, 0.55, which is your pi, 1 minus pi. Okay, square root of and divided by the number of sample size. So this one you should be getting, I hope you are also trying, 1.74. So you already convert here, so you can write your value here so that you can read from the table. Z more than or equals to 1.74. Okay, so like I've explained to you, because this is more than, okay, so you need to use this to get the value of Z more than 1.74. Okay, okay, so we refer again to slide 16 for this table. So 1.7 here, so 1.74, right? 0, 1, 2, 3, 4. So you get 0.9591. Okay. So we go back to the slide. So it is actually 1 minus 0.9591. So how much you should be getting here? Okay, so I hope you're also trying 1 minus 0.9591 here. You should be getting 0.0409. Okay. We move to the next example. Assuming that the proportion of voters supporting A statement is pi equals to 0.4, and what is the probability of a sample of 200, so n equals to 200, having a sample rating between 0.4 and 0.45. Okay, so your P is between 0.4 and 0.45. You have sample size 200 and your pi is 0.4. So how do we proceed with this? Okay, it's the same thing, but just that it gives you a in-between value. Okay, so find your standard deviation of your proportion first. So this one. Okay, so how you want to find this? Using the formula, you can refer to previous slide. Pi 1 minus pi divided by your n. So you just plug in. You know that your pi is 0.4. This one is 1 minus 0.4 divided by 200 square root of this. And you should be getting 0.03464 here. Okay, so you have already the value of your bottom one, which is your standard deviation of proportion. So you convert to standardized normal. So how you convert this? You use the formula, but because this is in between, right? In between 0.4, 0.45. So you can plug in 0.4 minus 0.4 divided by what? 0.3464. That's why we calculated this in advance for the ease of calculation here. Okay, you can also just calculate inside here, but it will look like lengthy and it will lead you to some maybe careless mistake in calculation. So you can separate it. Okay, and then you just put in here. Okay, so it is in between. So you convert it into Z, right? Once you use this formula, so you put Z for the in-between one. Okay, so 0.45 minus 0.40 divided by, so this is 4. 0.3464. Okay, so basically you'll be getting 0 in between in between 0 and 1.44. Okay. Okay, so once you have already get that Z value, right? So we refer to the Z table. So we know that from our answer just now, we get the P is in between 0 and 1.44, right? So we refer to 0, which is 0 0.5, and 1.4, 1, 2, 3, 4. You get 0.9251. So basically, it is equal to 0.9251 minus 0.500. So you should be getting 0.4251. Okay. So for after you use the cumulative normal table, so once you calculate like I've shown to just now, okay, 0.9251 minus with 0.500, so you should be getting 0.4251. Okay, so from sampling distribution into standardized normal distribution, so it is in between here, right? So this is your p value you see here from this graph, and after you convert it into standardized normal distribution, you write it as Z because it is in between Z value of 0 and also 1.44. Okay. Okay class, so we have come to the end of our discussion on the samples examples that are being shown in this lecture notes. Okay, I hope that my explanation is good and being elaborated in details for you to understand these lecture notes, and I hope it helps your understanding. Okay, so please go through and try out the example. Okay, and we meet again in our next lecture, okay, for our next topic. Okay, so please stay safe, take care, and thank you.